This next problem is a little bit more complicated than that. We're given several graphs to choose from. The parent cosecant function is shifted 4 units right and 3 units up. And we're being asked to identify which graph they're talking about. So just real quick off to the side, let me give you a brief lesson on how we graph a cosecant function in the first place. Well, cosecant is the reciprocal of the sine function. Cosecant is 1 over sine. So if I want to graph a cosecant function, that's going to be based off of the graph of the sine function. Okay, so that's what we're going to do. So the first thing I'm going to do is I'm going to graph the sine function, and then it will be easy to see where the cosecant function will sit. Okay, so we have memorized that the sine function, unshifted, begins at the origin, and then it goes up and down, all right, back to the midline, and then it goes down and back up. So this is what the sine function looks like. This is one period of the sine function. All right, I should probably label these. So this is pi, and this is 2 pi. Okay, I'm also going to do the other side. So this is negative pi, and this is negative 2 pi. Okay, so here is another period of the sine function. If I were to continue this going to the left, it would look like this. Okay, so this is obviously a really rough sketch, but this is a sketch of the sine function. Now, the way the cosecant function works is, first of all, there are asymptotes in here. Okay, what would be a good color for my asymptotes? I think I'll use gray. There are asymptotes wherever the sine function touches the x-axis. Okay, so there should be an asymptote right in the middle, right here. There should be an asymptote here. Okay, and there's an asymptote here. So there's an asymptote every pi units. Okay, now, so this is just the sine function. Now, what about the cosecant function? Oh yeah, the y-axis is also an asymptote. The cosecant function is going to be the same right at the top of the hill here, but then it's going to approach the asymptotes. Okay, so it's going to approach the asymptotes on the left and right, so we get a little loop right here. It's going to do the same thing at the bottom of a dip. So the cosecant function will be here, and then it will approach the asymptotes on the left and the right. Okay, you'll forgive my drawing, I hope. Okay. So just as a really rough sketch, this is what one period of the cosecant function would look like. And the cosecant is just the red part. Okay, everything else is just a guideline. So the question is, how will this change if I move it, what did they say, 4 units to the right and 3 units up? Well, let's think about the easiest part of that first. If I were to move this entire graph 3 units up, that means the midline, instead of being on the x-axis, the midline right through the middle would be at 3. So the first thing I'm going to do is look at the answer choices and see where the midline is. If it's not at 3, then I know that's not the answer. So looking at this graph, here's a line that goes right through the middle of everything. All right, that's at -3. All right, that would be shifted down 3 units. So I know that this is not the answer. Okay, if I look at this graph, the midline is at 3, so this is a possibility. Okay, here the midline again is at 3. This is shifted up 3, so this is a possibility. But here the midline is at -3, so that's no good. Okay, so we've narrowed it down to kind of a 50-50 chance here. So now let's talk about shifting 4 units to the right. Okay, and what would that look like? Shifting 4 units to the right. Okay, now here's the key. Remember that pi is approximately 3.14. So if I shift 4 units to the right, that means I'm shifting to the right a little bit more than pi. Okay, a little bit more than one of these spaces on my graph here. All right, so let's focus on this period of the sine function, and let's imagine shifting this over a little bit more than pi. All right, because we want to shift 4 units. And of course, that's a little bit more than 3.14. So look at the first point. If I shifted this over a little bit more than pi, that would be here. Okay, look at the middle point. If I shifted, okay, this would be pi, and here's a little bit more than pi. Okay, and look at the final point. Okay, here would be pi, here's a little bit more than pi. So this period of the sine function would look something like this. Okay, now that means that the cosecant function would look something like this. All right, the cosecant function has points at the top of the hill and the bottom of the valley. Okay, and then it stretches out towards the asymptotes and makes these little loops. So there'll be a loop here and there'll be a loop here. Okay, so let's look at the 2 graphs that we have left and see which one of them has a loop, an upward facing loop, a little bit to the left of the y-axis, and a downward facing loop to the right of the y-axis. Okay, well, look at this graph right here. See how we have an upward facing loop, okay, a little bit to the left of the y-axis. And here we have a downward facing loop to the right of the y-axis. Okay, that would match what we came up with. Let's look at the other example and see if that's what we have. Well, to the left of the y-axis, we have this downward facing loop. Okay, we wanted an upward facing loop like this. To the right of the y-axis, we have an upward facing loop when it should have been a downward facing loop. So this is going to be the right answer.